All right, guys. How you guys doing? This is what quick review on how to convert mass to moles and using molecular weight. This is kind of continuing reviewing on what we from last year. And let me get my pen set. All right, looks like we're good to go. So let's take a look at this. So we're going to calculate molar mass. This is also formula weight, molecular mass, formula mass. We kind of use the same thing over and over again. I know some people are more particular than others, but we're talking about the same thing. And a lot of times we see molar mass abbreviated as MW, molecular weight. So to calculate this is iron 2-phosphate. We just go through and calculate, figure out how many atoms of each we have. So iron, we have 3. We have 2 units of PO4. So in each phosphate, PO4, we have 1 phosphorus. Since we're having 2 units of PO4, phosphorus is 2. And oxygen, 2 times 4 is 8. So just distribute the 2 through what's inside the parentheses. Now, when we're looking at molecular weight for our oxygen, we're going to round to the second decimal point. So this is going to be 16.00. We want to go to the second decimal point. This is going to help you keep the answers consistent with everybody. A lot of periodic tables have digits past the second point. I understand that. Don't use those, because what happens, each periodic table has a slightly different mass for all these elements. Some are older than others, some are newer. And it depends who they get the information from. So just to point out is that you gotta go to the second decimal point and round to that, and that's it. So phosphorus I have in the book is going to be 30.97. I'm using the table of atomic masses from the textbook. And then iron is going to be 55.85. Now, if you guys are going to ask, does it matter where we get this information from? Not really, because all the numbers are going to be the same to the second decimal point. It's past that is where we see the differences. So if you round to the second decimal point, you guys should be fine. So 55.85 times 3, because we've got three atoms of iron. Whoops, I'm 55.85 times 3. And we're going to have 167.55. Then 30.97 times 2. And you're going to have 61.94. And then 16 times 4, and you get this nice even 64, and we'll go 64.00. Now we're going to add these up. So 64 plus 61.94 plus 167.55. And you're going to get 2, and hopefully this is right, 7, 8, yep, 293.49. And the units for this is going to be grams per mole, because we're looking at 1 mole of the material of this compound, iron 2-phosphate, and that's how much it weighs, 293.49. And we're going to use this information to figure out, if we're giving you moles, how much mass we have, and vice versa. So moles of, if we're given 2.58 moles of iron phosphate, what's the mass? So this is what I want you guys to do on your paper. And let's go ahead and start off with 2.58 moles. And put the compound that we have. This is organization. And right now I'm trying to train you with this organization. Those who are going into this field, it's going to help you a lot when we do some in college. If you're not, just bear with me. Just go ahead and do this. So what we have is that we need to know the molecular weight of iron oxide. And we know that's going to be 200, and we need the grams on top and the moles on bottom. Why? We're going to get rid of the moles. And we know the atomic weight, molecular mass is going to be 293.49 grams. Now realize is that with these units, if I just put this down, put this as 1, the mole and mole is going to cancel, and I can carry everything else through. So multiply the top, my moles cancel. I am going to have times 0.258. My answer is going to be 75.72. And be honest, I got 3 digits over on the left, so it's just going to be 75.7. Don't need 2 grams of iron to phosphate. Don't get confused by this 3, because that's the charge on the phosphorus. This is the charge on iron, so it's to balance everything out in the element, it's going to be iron 2 phosphate is the actual name. Iron 3 phosphate is just FePO4. So this is how you convert moles to mass of a compound. So now, next example. Now we got 225.14 grams of iron to phosphate. We want to know how many moles we have. I'm just keeping the format on these type of problems are going to be the same. So you got 25.14 grams of Fe3PO42. Remember, I'm writing everything down on this. Now I know it's going to take some paper, but this is what I want you guys to do. Now, I want 1 mole of my compound, so I'm putting in but I want to get rid of grams, so I'm going to put the grams, the 293.49 on the bottom, because what I want should be on top, and what I have needs to I need to put it on the bottom and get rid of it. So the grams cancel. So 25.14 divided by 293.49, and you're going to get 0.0865 or 857. And it's going to be moles of Fe3PO4. Whoops. Let me write this on the bottom, Fe3PO4 2. And that is how you convert moles to mass and mass to moles. If you have any questions, let us know at the end of the slide. And thank you guys for your attention.